Welcome to Ask and Learn.
So for this problem, we first want to consider what the graph is going to look like. So when we take the square root of an x squared function, it gives us something like the absolute value function, as we see right here. And then when we add the 4x, it'll be very similar. The only difference is that it's going to separate the range at which we can have values. It's going to change the domain slightly. Like here, we saw it shifted it 4 units to the left, and it caused this big gap right here. So all these values are undefined. But we're mainly focused on these slant asymptotes. We notice that there are 2 slant asymptotes, as the problem suggests, and they're going to go along this line right here and this line right here. So one of them is going to have positive slope, one of them is going to have negative slope. If we look at y equals x, for example, we see that the slope appears to be good, but we're definitely going to want to shift it upward. So we'll do x plus 1. We still need to shift it up, so we'll do x plus 2. This appears to be an asymptote, and as we go out closer to infinity, we see that they never intersect. There's never a point of intersection. Okay. Then we can look the other way. It's going to be somewhat symmetrical. So this is going to be y equals negative x. Y equals negative x. And once again, we're going to need to get it closer to that line because there's still a bit of distance. So when we do minus 2, we see that it's approaching that line at a much closer distance. However, as we go out to infinity, we see that it still is never intersecting. Therefore, we do have 2 slant asymptotes, x plus 2 and negative x minus 2.